Hi guys, in this lecture video, I'll be discussing the two measurement systems, the metric system and the English system, with emphasis on the metric system. So we'll go over the 7 fundamental physical quantities and the base unit for them. And we'll also talk about derived units as well. And we will focus particularly on a very important derived physical quantity that we call volume. So let's get started. First one, there are two measurement systems that are out there. One is called the metric system, and the other one is called the English system. So the metric system is the measurement system that is used by the entire world, and the units derived from the metric system are then called the SI units. And this SI right here stands for International System. And here in the US, we use the English system. So this is only used in the USA. And the units in the English system are then called the non-SI units. And some of the examples of these types of unit include the following. In the metric system, we see units such as meter, millimeter, kilometer, and so on. And some of the examples of units from the English system include pound, feet, inch, and etc. Here is the important part right here. All scientific measurements are then made in the metric system. So therefore, as we learn science, it is very important that we are getting used to the metric system. And this is why this lecture right here emphasizes on the metric system. So now let's talk about the metric system units. So in our entire world, there are 7 fundamental physical quantities of matter that are out there that we need to be able to measure. And so therefore we establish there are 7 units that we call the base unit to measure these 7 fundamental physical quantity. And this fundamental physical quantity that we need to be able to measure in our life includes the following. Length. So as you can see, it's important that we are able to measure length. And then mass, and times, and temperature, and amount of substance, and electrical current, and luminous intensity, or how bright something is. So these are referred to as the 7 fundamental physical quantity of matter that we need to be able to measure. And in the SI system, there are 7 base units that have been established to measure or express the units of this 7 fundamental physical quantity. And the base unit of length is meter, versus the base unit of mass is kilogram, and for time it is second, for temperature it actually is Kelvin, but not Celsius. And the amount of substance is then mole, and then ampere, and then candela for electrical current and luminous intensity. And these are the abbreviation of these 7 units that are good for us to commit to memory, because we'll be seeing this very, very often. So for a meter, it is abbreviated with an M, and kilogram is kg, as what we have seen already. Now let's focus on some of this physical quantity, and one that is important for us to go over would then be mass. And now with mass is actually different than weight. So please remember that. Mass is basically a measure of a quantity of matter, versus weight is basically the measure of the force of gravity on matter. So weight is basically gravity dependence, versus mass, it is always constant. So the mass of an object is always constant, versus the weight of an object varies dependent on the force of gravity. So therefore, on the Earth's surface, mass equal to weight. So this is why that we see both of this terminology right here are being used. So you would weigh something to find the mass of that something. Now, if you were to go out of space where there's no gravity, then that when mass and weight are no longer the same thing. You can have an object with mass equal to 150 grams, and now its weight would then equal to 0 kilogram when it is out of space. So that's the differences between mass and weight that you need to remember. And now we'll go over some of the derived physical quantity and units. So all other physical quantity are called the derived physical quantity, and their units are then derived from the 7 base unit of what we have seen above. So whatever we don't see here, we call them the derived physical quantity and the derived unit. For an example, density is a derived physical quantity, and volume is another derived physical quantity, and then velocity or speed of velocity is also another derived physical quantity. Now the unit of density is gram over milliliter, and here in this case right here we see gram here, which can be converted from kilogram, and we also see here milliliter as well. So clearly it's nothing than what we have seen above here, and the reason why it is a derived unit, it has all the components that are added in or included in it. And volume is basically milliliter or cubic centimeter. That's the units. That's some of the example of unit of volume. And then velocity, for an example, mile per hour. So here in this case right here, we see miles, which is unit of distance, and then hour, a unit of time in it. So basically, this is why that we call this the derived physical quantity, because the units combines unit from the 7 fundamental quantity that we've seen above here. And now, let's now go over volume, because volume is a very important derived physical quantity that we use that we use a lot in chemistry. And by definition, volume is basically the amount of space that an object would occupy. And there are 2 distinguished types of unit for volume. So this is a derived physical quantity, and there are 2 distinct types of unit for it. The first one is something that we call the typical units. Now, so typical unit are the normal types of unit that we use for volume all of time. For example, in the metric system, some of the unit volume that we use very, very regularly include liters or milliliters. Versus in the English system, some of the unit volume that we use very often include gallon and maybe ounce, fluid ounce, and etc. So these are the types of unit that we call the typical unit, because these are normal types of unit that we use for volume. But in addition, here is another way to also express the unit volume, and that is the cubic length. So or length raised to the 3rd power. So basically the volume of an object can also be obtained by measuring its dimensions. So if we were to actually have a liter of liquid, okay, so here in this case a liter, which is a typical unit of a liquid, and if we were to have a liter of it, and now if we put that into a cube, then the dimension of the cube will be as follows. So this cube right here would have the length equal to 10 centimeter, and the height of 10 centimeter, and the width of 10 centimeter as well. So that would be the volume of this object right here, if we were to have a liter of liquid and we pour that into this cube. Now, as you may recall from math classes already, volume equal to length times height times width. So in this case right here, the volume of this cube right here would then equal to 10 centimeter multiplied by 10 centimeter multiplied by 10 centimeter. So it would then equal to 1,000 cubic centimeter. So when we multiply 10 by 10 by 10, we have to also multiply the centimeter as well, and that's why it becomes cubic centimeter. So in this case right here, we can see that 1 liter of liquid, and when we put this into this cube right here, it will have this volume. So therefore 1 liter is then equal to 1,000 cubic centimeter, right? And this is a very, very important relationship that we need to remember, because a liter, this is the typical units of volume that we have seen. versus here a cubic centimeter. Centimeter is basically length. So length cube. That's what cubic centimeter is. So in this case right here, the conversion factor between a typical unit volume to cubic length would then equal to, would be the 1 liter equal to 1,000 centimeter. And this is a very important relationship right here that you need to remember in order to convert between a typical unit volume to length. Okay? Or the other one that we often remember will be as follows. 1 milliliter equal to 1 cubic centimeter. Okay? So this is actually the more common one that most people would remember. And if we were to divide this by 1,000 and divide this by 1,000, when we take a liter and we divide that by 1,000, we have 1 milliliter. And 1,000 divided by 1,000 will then equal to 1 cubic centimeter. And so where we get this relationship is also from the following. So if we were to now have this cube right here that is 10 by 10 by 10, and if we now take out one tiny little block in it, the dimension of this block right here will then be 1 by 1 by 1. So therefore its volume would be 1 cubic centimeter. And when we take out one of this, we essentially take out 1,000th of a liter, which then equal to a milliliter. And therefore that is where this relationship comes from. Okay, so please remember this, because this is how we can convert from a typical unit volume into length to the third power. Okay, and below here are some of the useful conversion factors among the different physical quantity. So within the physical quantity of length, we can have many units in them. For example, we can have inch, we can have centimeter, we can have meter in inch, and kilometer amount, and so on. And these are some of the common conversion factors between the metric system to the English system. So a centimeter is the metric system, an inch here is the English system, and here meter is the metric system, and inches here will be the English system, and so on. So these are some of the common conversion factor among length between the metric system to the English system. And over here are some of the examples of conversion factor within the mass fundamental physical quantity. So mass is again another fundamental physical quantity, and so there are many units in it. Some of the unit are the metric unit versus other are the English unit, and these are their conversion factor. A pound equal to 454 grams, and a kilogram equal to 2.20 pounds, and an ounce equal to 28.3 grams. And these are some of the conversion factor among volume. And again, please remember the volume is something that we call the derived physical quantity. Okay. And please note the following. Some of this conversion factor right here would be given on exam. Not every conversion factor will be given on exams, but only some. However, I will give you enough so that way you'll be able to figure out every problem without memorizing conversion factor. So in this chapter right here, here's some of the lists that you need to be able to do. First, be able to convert between units in a metric system and the English system, and be able to convert between a typical unit volume to cubic length, and that's important as well. Now, I will not be going over any of this example in this section at this point, because we will be going back to this after we have learned about dimensional analysis. So dimensional analysis will be the method that we will use to be able to convert this unit. And once we have covered this, we'll go back to learn how to convert units between the metric system to the English system, as to what we are asking you to do here.